Herzlich willkommen, ein neues Video. Meine liebe Elektronikfreunde, hier ist ein Schlumberger 4901. Oh, I'm sorry, I should of course do this in English, but this is a German product, so we need a proper introduction, right? Schlumberger, it's difficult to say in English, isn't it? 4901, radio frequency, audio frequency measuring unit. All right, so I guess this one will be used for radio equipment, transmitters, receivers, something like that. It is a little bit confusing. The audio frequency and radio frequency inputs, I don't really see any indication about low, high frequencies. What can it really do? And there's also this input. So how do you swap the different inputs? So this button, and how do you... I really don't know anything because I couldn't find any manuals online. It can of course do AM and FM modulation, all sorts of noise and distortion. It can check deviation and all those things you really want to test for and generate when you're making radio sets. RF power, transmitter and receiver. So what we should do is look a little bit at the back. This is a little bit heavy, 12.5 kilos. So I bet there is a lot of good stuff in there. And also, when you see the N connector, it reveals that this thing can probably go quite high in the frequency. Always, it's really good to look at the back. So the voltage selector. Ooh, that is difficult to change. Maybe you need to pull it or unlock it somehow. But at least it's set for 220, so I should be fine. So what is this? Remote control. 1 megahertz. That's a little bit weird, isn't it? And then some outputs. Offset thingy for something special. Made in Western Germany. So this reveals a little bit about the age of this product. And it's 4901G. So if anybody got a manual or a link to a manual and they know how old this is or anything, please link to it so we can find it. Oh, is there a screw missing? All right, let's power it up. Okay, we are powering up 229 and we're going to do this together. All right? Holy camoli. 49, 43 watts. Is this all? Oh. 17 watt. It's doing a little bit of blinkety. Look at that. I can hear some relay switching. There's clearly something really wrong. It's going to do the blinky here. See? Ooh, we have to power it off. Oh, okay, it's absolutely not working. Okay, so we need to open it and see what happens. And of course, as usual, we're going to do this together. I took out the 2 screws. Ooh, what the heck is that? That is a lot of wires and solderings and whatnot, some display stuff. And because it's doing a little bit of blinky and odd things, I think we should measure the voltages on the capacitors. We've also got some power supply stuff down there. See, I did unplug mains, so I should be able to how about those resistors down there? Well, that is pretty cool. It looks like somebody's been soldering around down there. Got a big, nice case full of all the RF goodies. Phillips caps. Ooh. Oh, yes. Somebody was in here. A screw is broken in there. And here is a really, really sexy attenuator. And probably a power bridge or power detector here. See, we got forward and reverse, probably some tracks in here. You can probably think about opening this one later and see how this is, what is in here. Here is the something. Yeah, but I think we need to look at the power supply first. Maybe we should take out the bottom plate and see what's going on from the bottom side. Aha, so here is a main disconnect for the power supply. Maybe we also got some wires here. Maybe I should take, I can feel something here. So I should take the thermal camera and have a look. So this is the bottom side. I just took out the 2 screws and then what have we? Ooh, lots of funny ICs. Oh, it looks like somebody was soldering here. This can't be good, can it? What is this thing you're doing? Ooh, is it in a socket? A 3-digit BCD converter module something. Some op amps and interesting stuff and some more RF thingies. But I'm looking for test points, something that has something to do with the power supplies or some readouts or some where are the voltages and what to look for, because it's definitely some power supply issues. Oh, look at that, semi-rigid, really nice. Goes into some sort of a coupler detector or something. Semi-rigid all the way to this module here in the back and whatnot. It's really beautiful, beautiful construction. Oh, we got 2 PCBs stacked here. A lot of stuff in here. And even this one goes down there, right? So this is 3, 2, 1. Yeah, can you see it? That is pretty cool. So there's a lot of good stuff to look at, but I think we should think about the power supply first of all. That's the main source for all the problems. Oh my goodness. What is all that stuff? That is not what I expected. A million relays and loose wires all over the place. What the heck is that? That is far from what I expected. So this is in the top case. My God, somebody really, really loved relays. That one is interesting. So this is a temperature matched pair of some sort. A lot of special analog components. I was just looking for something that was burned or blown up or something, because there's definitely something completely wrong. I still expect the power supply to be the problem, but I think it is possible to take out the entire power supply by unscrewing this, unplugging this. There's probably also some screws here and here that attaches the whole power supply module, and then this connector here. I don't know if I can get some light in here. This connector is, this cable comes out there. So this is also power supply. And I think if you take out the bottom plate, there's nothing really connected to that, difficult about that. So I could just take out all those screws and I will be able to access this and take out the power supply. Maybe I could also take out the two regulator controller boards in the power supply and see if something is visually broken. But it's just easy to open everything here and then power it up again with the thermal camera and look for something that gets really hot fast, because that is where the problem is. I don't know exactly how to show you guys this. I've just been powering it up and looking for hot spots, and I don't really see anything bad and nasty. This is quite normal. So this is the bottom side again. Let's look inside this one. I took out some really nice bolts. Oh, that is cute. This looks like some receiver stuff. Receiver, detector, mixer stuff. Really looks old. All those components like that. Still can't see anything visually broken. Also, listen to this. All those cases, that's actually PCB, and it's soldered together. Isn't it just cute? How you can make really sexy RF cases just using PCB and soldering. Exactly what I was thinking. So of course the bottom plate you can take out like that. That is actually really nice design. Good idea. This way you can access all the internal connectors and stuff from behind. Super easy. Because this is the power supply connector we need to take out. So we can take out the entire power supply and see what is going on with that thing. Oh, this took me like 5 minutes to figure out. Oh my god, that was difficult. To get this dumb power supply out. Oh man. Of course it was locked also by there was some air kind of locks here or something that makes the air flow more correctly through the fan. Fantastic. And then I took out all the 4 screws here. And then of course it goes out this way. Oh man, it's insanely difficult to get this out. Let me try and put this down again. See, this was those are the 4 screws, and they're made so they can't get lost. Look at that. See? They don't go away. Whoopsie doopsie. So this is the power output, and then I think I should be able to get this sucker out. Yippity. Come on, baby. You are out in the freedom. Say, we got a winner. And this is the baby that is not working, I would assume. So I think I will power this up and measure all the voltages and all the good stuff and see what is going on and where all the good juice goes. Oh, next little challenge. So this connector is actually this connector, and this cable goes all the way to the main switch. So it is connected with 6 wires. That is a little bit odd. 3 and 3 in 2 rows. That is, why would you do that? So it's shorting 2 of the pins when it is off. Why? So I need to figure out what is what here, and ohm check this. Otherwise there's no way I can power up the power supply without it actually being inside this unit, and I need to be able to access everything here. Maybe I can put it on top somewhere. So here's what I came up with. I always just find a common voltage on all capacitors, and I think it's this one, because between this one oh, that was wrong. It was this one, right? So the top blue one on this one is minus 30 volts, and on this one the bottom one is 0 plus 14 volts. This is of course what they use to make 5 volts, and here is plus 30 volts, and again 0. So this will be the 0 reference for everything. Now I can measure all the outputs in this connector. Now this is getting a little bit odd, what is going on here. See, I found those 3 black ones, they're all 0, 0, 0. Okay, fantastic. So far so good. But now look. Why can't I get a connection here? 7 volts, that is not regulated. Jumping up and down. Minus 39, that is exactly what is on the capacitors. Minus 8, again, not regulated, just jumping up and down. Plus 9, also jumping up and down like crazy. 25, jumping up and down. 6.7 something, again, jumping like crazy. And the same 7, I guess. So it's definitely a power supply out of regulation, doing all sorts of bad stuff. I could of course put a scope on this as well. I think I will try and connect this to the main board and measure the voltages under correct load, and then see what's going on. And this is exactly why you should not trash all sorts of stuff that you tear down. See, this is a PCB that I was playing with last week from another product, and it's easy to cut it out and reuse it for this one. So now I've connected everything here as the entry connector is looking like, and now when I measure the power supply alone, then I get minus 15, plus 15, and plus 5.5. So that means the power supply is working, or it is actually able to deliver the voltages without load, at least, right? So what I can now, I can input those voltages into the main unit and then measure what kind of current it's using, because I think there's an overload or a short circuit in the minus 15, but it could also be that the power supply is just not able to deliver anything at all on the minus 15. So that I need to figure out first before I can dig deeper into this. See again how handy it is to save goodies from previous teardowns. See, you can saw down one of the edge connectors from something else and use this to test this equipment, for example. So here we got all the different voltages input. I've connected it to 3 different power supplies here. So let's try and see what happens. This is plus 15, and this is +5. This looks all right. And this is the negative. Ooh, see? And I tried to crank up the current a little bit before, and then I heard some funny sounds in here. So I bet something is about to blow up, see? Let's listen for the crackety-crack sounds. Okay, this is time for thermal camera, and then boot this up. Let's see if this is affected. No, it is not. Woohoo, so I can play with the -15 alone. Oh, look at this. This is the bottom side, and this is I just had the 15 volts turned on, a few watts. Look, something here is really hot. Let's put on the macro lens that I made. Let's see if this can reveal what is hot. Ooh, a resistor. No, it's not a resistor. Where am I touching? Down there. So something here draws a lot of power. So I think I need to turn it on and off again, and then crank up the voltage really slow and figure out exactly where is it going. I think it's this. So this is probably just a filter inductor for one of those op amps, and this one is really hot as well. So I need to investigate a little bit here what is going on. But I think I'm getting closer. Oh, you gotta see this trick. Since this inductor contains a lot of DC resistance, I can't pull a lot of current through it because everything is just dissipated in this inductor. Now, my power supply here is complaining. Output is shorted because I'm inputting the negative voltage on the output side of the inductor to figure out where the heck is the short actually in this circuit. But look at that. Here is a capacitor that is hot. And the temperature is of course possible to feel now with the fingers, but it's really easy to see with the thermal camera. Super nice trick. And here is the shorted capacitor. So this is an easy fix with the nasty trickety trick thermal camera. So this is where it was, the shorted capacitor. I just bend it a little bit back and forward, and now it's out, and I actually got all voltages on everything. And so this is the -15, and this is the +15, and this is the 5.5. So it's actually using quite a lot of power. However, this thing isn't really doing a lot. It's reading 6, and then it is responding a little bit to this. I hear some clickety click. I can see. So now we are more inside. I just took the two boards apart. Look at my hand, and then this board. They're really big, and there is one more under this one as well. Look at the interconnects, how it's done between the different boards. This is actually pretty smart. I also see some programmable chips, right? Yeah, and they got numbers on them, so I think those are one-time programmables or fuse programmable logics. I can't remember them exactly, but I think this is something like that. I'm probably gonna look this up. So yes, this is the middle board. Let me see if I can get more in here. But I found another bug. Look at this cable. Somebody's been poking with this, and the shield is completely disconnected all the way around. This is the signal to this baby here. And this is the input connector for the transmitter test, where you transmit back through this coupler into an attenuator and a dummy load with some sort of attenuation. And this is where they will measure or get access to the actual RF feed. But out here, you can actually see the traces underneath this board. So that will be the coupling traces and a little adjustable capacitor and resistors and diodes, capacitors in here, and a little op amp. So this is how they made the power input detector. Really neat. Before I put the power supply back in the unit, let's have a little bit of close-up look on the details. Look at those two controller boards. We got some ICs, some power ICs. I wonder what they are doing down there. We got 3 of them, of course, because we got 3 different power supplies. Well, they're in sockets. Let's have a look what they can do. So that is the controller boards. I think those are the regulators and pre-controllers, and this is of course the output series regulator for the main power. 3055, of course. And if I'm not mistaken, this will be the negative supply, right? Because look at that. This capacitor got plus to the ground, right? And also, this one is called 1463. And the other two positive voltages, 1469. And again, trimmers. And when this is mounted like this, you'll be able to access all 3 trimmers from the side of the unit when you just take the side panel off. Actually pretty nice side connector here. And a single-sided board. Yeah. So now this thing is running on its own power supply. And with this power supply, the input power is 59 watts, right? Oy, oy, oy. Let's talk a little bit about efficiency and linear power supplies. Remember the power supplies I was using? There you have the real usage. I was doing one last temperature check all over this place before I was going to shut it down and give it back. But look at this. Where is it? Here it is. This one is interesting. It turns out the matched pair that I thought was a matched pair. Look down there, the 3 pins. This is the back side of a power transistor. So I'll bet they're doing something fantastic with temperature compensation of some very important circuit right here. Maybe some analog stuff. But again, I don't find any parts broken or hot, or everything turns out to be more or less normal. It's just dead. So without a manual and without schematics, I don't know what to do more. And really, I don't have any real usage for this. But what I would score is this one. This is definitely a great score. Thank you for watching. Bye.